Hello everybody. I'm going to do a short little lesson here for you on homogeneity and on the test for independence using chi-square values. Turn the camera around here just to show you what a crazy world we live in. Your lesson today is being brought to you from Shadyside Hospital up in Pittsburgh. My dad's having surgery today, and I'm doing this lesson kind of as a way of distracting myself at the moment while he's in the operating room. So here we go. The lesson needs to cover two things. It needs to cover real quickly how to do the null hypotheses and alternative hypotheses for these tests, and also how to calculate the expected values. So in this first problem, we're looking at, is there a relationship between between alcohol consumption, the level of alcohol consumption, and whether you're a male or a female. So is alcohol consumption related to gender? We've gone out, we've collected our data on this idea, and of course the first thing I want to do is I want to write my null hypotheses, and my null hypotheses is always going to include the word no. So there's no relationship here between the two of them. They're not related to each other, or there's no dependency between the two. And another fancy way of saying no dependency, or a simpler way of saying no dependency, is that these are independent of each other. The alternative to this, then, of course, is that they are dependent to each other. They are dependent of each other. So the alcohol consumption depends upon the gender of the individual. So again, remember, the key here is that you always put the word no in the first part of this. So, all right, to find the expected value, very, very, very simple. We've collected our data. What we need to do is we need to come up with totals. We need to have a total for each row. So there were 27 males. We need a total for the females. There were 49 females. We also need a total for each of our columns. So there were 23 that drank low, 25 that drank moderately, and 28 that were drinking highly. And then we need one more thing. We need what I call a total. And this really is just our sample size. So we can add this column together or this row together. The values should be the same, and the total here would be 76. Now, to get my expected value for each of these, I run a quick little calculation. And the calculation goes like this. You take the row total times the column total, and you divide it by the total, or you divide it by the n value. So if I want to find the expected value for male with a low drinking, my observed was 10. What was my expected? Well, I take the male row, which is 27, times the male column, or the low column, which is 23, and then I divide that by the total, which is 76. And the value I get for that is 8.2. My expectation was there would be 8.2 people in that particular category. I'll do this one. Okay, here I had males with high drinking. Okay, again, row 27. This time the column is 28, and I always divide by the total, 76. And my expectation in this one was 9.9. I'll do female moderate, just to kind of follow my pattern here. So female, 49, moderate, 25, total was 76. My expectation here was 16.1. It's really that simple. Honestly, it's kind of cool to me sometimes how simple things can be in statistics. Very complex ideas are kind of just wrote down to something very, very, very easy to do. So if you want to test and see if you're doing these are right or not, this one would be 8.9, this one was 14.8, and this one was 18.1. Okay, so this is the idea that we're going to use for testing independence, and we're going to use a chi-squared test to do this eventually. But for now, baby steps. We'll do the first two steps in the process, which is find the null hypotheses and find the expected values. All right, on this one, here we're testing what's known as homogeneity. And homogeneity is the idea that we're going to test if the proportions are equal between these. So is the proportion of passengers who lost luggage with each for each airline the same? So what I'd be saying here is that there's no difference in proportions. And sometimes this is also written that proportion number 1 is equal to proportion number 2 is equal to proportion number 3. That's a quick and simple way of doing this, saying this sentence without having to write the whole sentence. Remember, mathematicians are lazy people, they look for shortcuts. The alternative to this is that if there is no difference in the proportion, it's not that there is a difference, it's that at least one is different. Okay? All right, again, I need a column totals. Ooh, this wasn't supposed to be 100, it's supposed to be 96. So I get 100 there. I need a column, I need row totals. So this one's 21, this one's 279, and I need total totals. And in this case, I have 300. Now, what's neat here is because I'm doing proportions, it makes sense that I look at equal sample sizes. So when I take 100 times 21, row times column, I get 100 times 21, and I divide that by 300, I'll get a value of 7. But when I move over here, I'm still doing 100 times 21 divided by 300. So these top row, because my sample size was the same for each of the airlines, because I'm looking at proportions, percentages, and it's kind of nice it even worked out to be 100%, these values are always going to be the same as I work my way across here. And that'll be true for the second column as well. 279 times 100 is 279 100 times 100. And divide that by 300. Row total times column total divided by total gives me a value of 93. And that'll be true for all 3 of these as well. So those are my expected values for each of these. And then what we'll do is we'll run our little test on this in the next part of this. And we'll do what we did before, which is observed minus expected divided by expected. Add them all up. We'll compare it to a critical value, which we'll talk about. We'll talk about how to calculate that critical value using a contingency table next week. And we'll be able to run a test on these and see whether or not is alcohol dependent upon your sex, consumption dependent upon your sex, or is do airlines lose your luggage with the equal proportions? 2 kind of silly problems, but hey, they work for what we're doing. All right, that's it. I promise to keep it short. It's 8 minutes and 19 seconds in. As always, I tell you, be safe. If you need anything, you know how to get a hold of me. Take care, everybody.